There are three ways you can multiply vectors. Firstly, you can multiply a vector by a scalar. So if you have a vector and you multiply it by 2, you get a vector in the same direction that is twice as long. Secondly, you can multiply a vector by another vector and get a scalar result, which is sometimes called a scalar product as the answer is a scalar, and sometimes called a dot product as it is represented by a dot. Thirdly, you can multiply a vector by a vector and get a vector result, either called a vector product or a cross product, as the notation for this is, you guessed it, a cross. In this video, we will look at cross products. The cross product of two vectors is a third vector that is orthogonal, which means at right angles, to the two vectors. You can find the direction of the cross product using a right-hand rule, where you point your first finger in the direction of the first vector, your second finger in the direction of the second vector, and then your thumb points in the direction of the answer. This means that B cross A is not the same as A cross B, as if you change the order you multiply the vectors, your thumb will point in the opposite direction, meaning B cross A equals the negative of A cross B. There are a couple of ways you can calculate a cross product. One is by multiplying together the magnitudes of the vectors, the sign of the angle between the vectors, and a unit vector orthogonal to both the vectors found using the right-hand rule. This leads to the first important question. What do you get if you cross an elephant and a banana? The answer is the magnitude of the elephant vector times the magnitude of the banana vector times the sign of the angle between the elephant and the banana in a direction orthogonal to both the elephant and the banana. The second way to calculate a cross product is by finding the determinant of the matrix with the first row of Cartesian unit vectors, the second row with the Cartesian components of the first vector, and the third row with the Cartesian components of the second vector. On to our second important question. What do you get if you cross a rock climber with a mosquito? Nothing. You can't cross a scalar with a vector. Cross products are used in many ways. For example, the magnitude of the cross product of two vectors is equal to the area of the parallelogram, which has the vectors as its sides. An example of cross products in physics is the force on a conductor carrying an electric current in a magnetic field. This leaves us with one final question. What do you get if you cross an elephant with a fish? Swimming trunks! Thank you for watching.